Hello student, welcome back to my channel, and this is the second session of the chapter polynomial. So in the first session I have started just the introduction of relation between zeros and coefficients. Okay, and this is actually the second topic, rather I have started it first. So this is the first topic that I have done, and the second topic that I'm going to do, that is um, geometric representation of zeros. In some book, there in zeros spelling is written like ZEROES. In some books, it is written ZEROS. I'm just writing ZEROES. Whatever you like, you please write down because spelling doesn't matter. Representation of zeros, that means, suppose you all know that coordinate geometry means coordinate planes. So x-axis, y-axis, x o x dash, y o y dash. Now suppose you are just drawing a line, that means a linear equation's geometric representation is this. Okay, now you all know that these points, the points on x-axis, all points on x-axis will be looking like a comma 0, right? A may be positive, negative, anything, but it will be looking like a comma 0. That means its x coordinate will be there, but y coordinate always will be vanishes. That means y coordinates value always will be 0. Now here also there is a point, this is on y-axis, so why actually we are not concerned about the points where the line or any curve cuts y-axis. We will be looking at only the point where the curve or the line meets x-axis, only x-axis. Again, I'm just repeating, x-axis meeting point with the curve or straight line. Now one thing, that in this scenario, in this figure, you can see this line cuts or meets the x-axis at one point, means this curve or line has 1 0, only 1 0. And everybody knows this is linear equations. Representation is a line, straight line on coordinate plane. Now linear equation means 1 degree equation. 1 degree equation means one solution. So it's 1 0. Coming to another figure, just some random figures. This is x-axis again, and this is y-axis. This is origin. Like this, suppose the curve is like this. So again I'm telling, we will be looking at the meeting point of the curve with x-axis. So how many? 1 2, that means 2 zeros, right? In the same way, suppose another one I'm drawing like this. How many? I think everybody can answer. I'm just giving you 1 minute to think about it. Not 1 minute, few seconds. Okay, I'm now giving you the answer. There are 3 meeting points with x-axis, right? 3 meeting points. 1 2 3. That means how many zeros? 3 zeros. Clear up to it? Then coming to another figure. X O X dash Y O Y dash. Suppose it is like this. The curve is like this. Means the curve just touches x-axis. Touching means meeting point is only one. So this obviously 1 0. One meeting point 1 0. Three meeting points 3 zeros. Two meeting point 2 zeros. Means the final figure that I am going to draw like this. Suppose a curve is like this, or a curve is like this. You can see in both these curves, these two curves will never meet x-axis. As these two curves will never meet x-axis, means they have no zero. I think everybody got the clear idea. Again I'm repeating. Geometric representation of zeros, that is number of zeros, how can you find out from a figure? So you don't have to find out, you don't have to calculate it, rather just looking at the figure you can find out the number of zeros. It's very easy. So I'm just repeating it very quickly. One meeting point with x-axis for a linear equation, which is very obvious, so it has 1 0. Now two meeting point, that means two zeros. Three meeting points, that means three zeros. One touching point, that means one meeting point, that is 1 0. And now there are no meeting points in these two figures with x-axis, that means no zero. So this was my second session and the second topic, geometric representation of zeros. So, and this was the topic that I have just covered, and related to this topic there are exercise 2.1 from NCERT class 10. So this will be your homework for this session. Thank you all.